Hey guys, I am back with the second video of the video series on materials, metals and non-metals, class 8 science. So in this video, we will learn about non-metals, physical properties of non-metals, and then we will start with the chemical properties of metals. So are you all ready to learn with me? Let's get started. So now we have discussed about the physical properties of metals. We saw that metals are malleable, ductile, sonorous, with high density, good conductors of heat and electricity. So now let us talk about non-metals. So first we will start with the definition of non-metals. So these are those substances which are electronegative in nature, just the opposite of metals. So here they do not have a tendency to lose electrons, rather they want to gain electrons. So whenever it is metals, so you can say that metals are like they believe in giving, so they release electrons, whereas non-metals, they are the takers, they want to take electrons, so they will gain electrons. So examples of non-metals are carbon, sulfur, iodine, oxygen, hydrogen. Now if you see, most of the non-metals, they are either solids or gases. However, there are exceptions to non-metals which are liquid, for example, bromine. So bromine is one such non-metal which is liquid. So in non-metals, what happens is, inside the atom, inside that substance, you have same number of electrons and protons. But in this case, they want to get additional electrons. So additional electron comes in, and therefore overall the substance becomes electronegative in nature because there are more negatively charged particles. So here if you see, now since it has taken additional electrons, so it is taking additional negative charge. So obviously overall charge will become negative, and that is why they are electronegative in nature. So these are non-metals. So I have already explained you what does it mean about to take electrons or to release electrons. Now the question is, why do we study non-metals? So where do we use them? Now again, the uses of non-metals are also huge. We actually cannot survive without them. So if you think of non-metals, if you think of the gases like oxygen and carbon dioxide, so you see that living organisms survive due to the presence of oxygen and carbon dioxide. And oxygen and carbon dioxide, these are all non-metals. Carbon dioxide is made up of carbon and oxygen. So carbon is also a non-metal, oxygen is also a non-metal. You look at the plants. Plants take in carbon dioxide during the process of photosynthesis and they give out oxygen. Now, without these two gases, plants can't survive, and this oxygen again is taken in by the animals, including we human beings, and we give out carbon dioxide. So these non-metals help us to survive. The survival of life depends on the existence of these non-metals. Not only that, if you look at the rockets, the combustion of fuel needs oxygen. So oxygen again is a non-metal. You look at the composition of air. Air contains 78% of nitrogen. It contains 21% of oxygen. So nitrogen, oxygen, carbon dioxide, argon, all these non-metals together form the air around us. So not only this, if you see these gases like nitrogen and oxygen, carbon dioxide, they not only form the atmosphere, nitrogen is also very, very important for the growth and development of plants. Apart from that, we also have fuels which are excellent sources of energy. For example, coal. So what is coal? Coal is made up of carbon. And what is carbon? Carbon is of course a non-metal. So coal is again an excellent fuel, excellent source of energy, and we have already studied in our previous lesson that there are so many different uses of coal. Again, if you talk about diamond, it is again made up of carbon. It is, in fact, it is one form of carbon, and diamond is used for making a lot of jewelries. Graphite, which is present in the batteries or the pencil leads, so that also contains carbon, which is again a non-metal. The neon lights which you see on in the shops or in the discs or even in the streets, so these neon lights are also made up of neon, which is again a non-metal. In fact, there are non-metals like hydrogen and helium which are present inside balloons, the gas balloons, which just go, when you leave it, it just goes up high in the air. So it contains hydrogen, helium, so they are also non-metals. You would have also seen that in the swimming pools. Now, the swimming pools contain so much of water. There are chances that infection or the water gets dirty because there are so many organisms, insects, and everything inside the water. So therefore, you would have seen that chlorine is applied in swimming pools for keeping away infection. So what is chlorine? Chlorine is again a non-metal. So all these chlorine, neon, hydrogen, helium, carbon, so these are all examples of non-metals. Not only that, in fact, non-metals are also used in a lot of antiseptics. For example, iodine. Yes, the same iodine which is present in salt, the iodized salt. So iodine is also useful in preparation of a lot of antiseptics, and that's how we see that even non-metals are also used in our day-to-day life. In fact, forget about day-to-day life. We are surviving due to the presence of these non-metals like oxygen, carbon, nitrogen. Life forms would not exist without these. So it is equally important to talk and to discuss about non-metals as well. So again, in a very similar way, here also we will start with the history of non-metals. Well, non-metals were the only non-metal which was discovered during the prehistoric time was carbon. Now that is quite surprising, right? You remember when we talked about the history of metals, we saw that gold was the first one to be discovered in 6000 BC. But gold was not the only one. There were many other metals like copper, iron, which were discovered during the BCs. So during the prehistoric time, a lot of metals got discovered. But compared to that, only carbon was the only non-metal which was discovered during the BCs. And that too, carbon was discovered in the form of coal. Now, one reason behind this is when you talk about metals, they are all solids, so you can actually see them. So discovering them is easier when compared to these non-metals which are mostly in the gaseous form. So you really cannot just imagine that okay, carbon is present here, oxygen is present here, or nitrogen is present here, because they are in gaseous form. So it is little difficult to find them or to prove their existence. But however, over a period of time, gradually other non-metals were also discovered. The next one to be discovered was phosphorus, which was during the 13th century. So there was a long gap between the discovery of carbon and phosphorus. Now when phosphorus was discovered, it was mostly used in explosives. Why it was used in explosives? Because of its reactive nature. So we will talk about all that. Next was oxygen, which was in 1774. So you see, oxygen is something which is so much important, right? Like oxygen is present in our atmosphere. The air is composed of almost 21% of oxygen. In fact, the entire earth has almost 50% oxygen, because when you talk about the oceans contain what? Water. Water is hydrogen and oxygen. So oxygen being such an important element on earth, it was discovered very recently, because 1774 is not long ago. So it was discovered quite recently. Then gradually all other non-metals were discovered, like nitrogen, chlorine, sulfur, hydrogen, and so on. So that's how the non-metals were gradually discovered. Another interesting thing, if you compare metals with non-metals, is that if you look at the number of metals, they are more when compared to the number of non-metals. So in non-metals, you have comparatively lesser number of elements when compared to the number of metals. So quantity wise, so that wise, the number of metals and number of non-metals, metals win. But when you look at the amount of metals and amount of non-metals which are found on earth, then of course non-metals win, because the quantity of non-metals is definitely more on the earth. You talk about oxygen, you talk about nitrogen, you talk about carbon, they are all present in huge amount on the earth. Oceans have hydrogen, oxygen, atmosphere have nitrogen, oxygen, carbon. So that ways the existence or the quantity of non-metals is more on the earth when compared to metals. But when you look at the elements, how many of them are metals and how many of them are non-metals, you see that there are more metals than non-metals. So now let us quickly get into the physical properties of non-metals. Now we are going to discuss exactly the same physical properties which we had discussed for metals. So the first physical property was luster. So in metals we saw that they had a shining appearance, they had a shining surface. But in case of non-metals, they do not have any shiny surface. The best example that you can consider is maybe wood. Wood contains carbon, again coal contains carbon. So a lot of stuffs contain carbon. So if you think of any of these, you can see that they do not have any shiny appearance like gold or silver or copper does. Not sonorous, they do not produce any sort of ringing sound like how metals produce. So you really can't have a bell with wood. Not malleable, not ductile, you definitely cannot. If you start hammering a wood, what will happen? The wood will break into pieces. Similarly, if you start hammering coal, what will happen? It will again break in the form of powders or small pieces. So you will never be able to beat coal or wood or any other non-metal to form a wire or to form a sheet. So they are not malleable, not ductile. Poor conductors of heat. They cannot conduct heat, so they are extremely poor conductors of heat. So if you put, now when you burn coal, they can generate heat. So generating heat is something else. Generating heat means they are producing heat, but they cannot conduct heat. So if you put coal over fire, so the coal will start burning. It will not be able to conduct the heat to some other object. So you really can't cook with a vessel made of wood or with a vessel made of coal. They are also poor conductors of electricity, and that is why your wires are made up of metals and not of wood or coal. Now why I am taking examples of wood and coal, because that is something you can more easily relate to. So you think of a circuit like this, where you have a bulb, you also have a battery. So this is the battery, this is the bulb. Now when you connect the bulb to the battery, these wires are the metal wires, okay? So now the wires are metal wires. So metals are good conductors, but in between you have put a plastic bottle. So this plastic is a poor conductor. Now even though the circuit here is complete, what happens? Now since this plastic is a poor conductor of electricity, so the path of the electric current is not complete, and therefore the bulb doesn't glow. So this shows that non-metals are poor conductors of electricity. They are comparatively soft when compared to metals. They have low density. Of course, like you talk about iron or copper, they are extremely heavy, they are very dense, but non-metals are not like that. In fact, when you talk about metals, they are all solids, they are mostly solids. When you talk about non-metals, they are mostly gases or solids. The only exception is bromine, which is a non-metal, but still it is a liquid. Now, so far we have discussed all the physical properties of metals and non-metals, but there are certain exceptions to the physical properties which we have discussed. So let us quickly look at the exceptions. Mercury is the only metal that exists as solid at room temperature. I'm so sorry here, this is not going to be solid because most metals are anyway solid. Mercury is the only metal which is liquid at room temperature. So have you ever observed your thermometers? So inside the thermometer you see a liquid present which is kind of shiny, a shiny liquid, and that liquid has a special property that it never sticks to the walls of the thermometer. So that liquid is nothing but mercury. So mercury, otherwise all the metals are solids. So mercury is the only metal which exists as liquid, but still it is a metal. Metals having high melting points. except gallium and cesium. So these are the two metals which have very low melting points, but otherwise metals have high melting points, and that is why they are used for various purposes. Like metals are used in the filaments of bulb, they are used for making utensils, because they will not melt easily. But the exception to that is gallium and cesium. Iodine is a non-metal that has luster. Normally, metals have luster. Metals have shiny surface and non-metals do not have luster. But the only non-metal with luster is iodine. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting and boiling point. Now, normally we say that metals are hard and non-metals are soft, but diamond is an exception. Diamond is made up of carbon, but diamond is the hardest substance. So, diamond is harder than all the metals we have spoken about. So, that is one exception. Again, we say that metals have high melting points, but diamond, even though a non-metal, again has high melting point. So that means diamond falls into exception list of two properties. Graphite, which is another allotrope of carbon, is a conductor of electricity. We say that non-metals are poor conductors of electricity, but again graphite is the only exception because it is a good conductor of electricity, but it is a non-metal. Alkali metals like lithium, sodium, potassium are so soft that they can be cut with a knife. They have low densities and low melting points. So these metals, like mostly metals, are hard. That is why when I was talking about the physical properties, I told you that based on the physical properties alone, we cannot say whether a substance is a metal or a non-metal, because different metals will behave differently for each of the properties. So therefore, we categorize any substance as metal or non-metal depending upon whether that particular substance is electropositive or electronegative in nature. Now, you look at these metals, lithium, sodium, potassium, they are all metals, but they are not hard. But we say that metals are hard. They also have low densities, but we say metals have high densities. They also have relatively low melting points, but again we say that metals have higher melting points. So there are quite a few exceptions to the physical properties of metals and non-metals, and these were the ones. So now it is time that we talk about the chemical properties of metals, because in physical properties we just spoke about the appearance, the external properties, the external behavior of metals and non-metals. Now we will see that how these metals react when they come in contact with some other chemical substance. So how that reaction happens and how those reactions are different in metals and non-metals. So that is what we are going to discuss in chemical properties of metals. So first of all, let us talk about how metals react with oxygen. Now where is oxygen present? Oxygen is present in the air. So if the metal is exposed to air, it should react with oxygen. So let us see how exactly it happens. Now, almost all metals combine with oxygen to form metal oxides. So, metals react with oxygen and they form metal oxides, and these metal oxides are basic in nature. So, we will talk about that later. Now, let us look at some of the chemical reactions. So, let us see how different metals react with oxygen. Now, any metal reacts with oxygen to form a metal oxide. So let us take some examples. Let us suppose if you consider the metal magnesium. So magnesium combines with oxygen to form magnesium oxide, that is MgO. So if you want to balance the equation, this is how it would be. So in fact, you would have seen this. If you want, you can perform this experiment in your laboratory where you take a magnesium ribbon and burn it. So when you burn it, so obviously it is reacting with oxygen because burning happens in presence of oxygen. So, and then what do you get? You obtain ash. So the ash which you obtain, that is nothing but this magnesium oxide. Not only magnesium, you take examples of other metals. For example, you take copper. So copper reacts with oxygen to form copper oxide. You take examples of aluminium. So aluminium also reacts with oxygen to form aluminium oxide, that is Al2O3. So all the metals will form metal oxides. In fact, Formation of this metal oxides can be evidently seen as well. So let us take the example of rusting. Have you ever seen that when any object which is made up of iron is kept outside, exposed to air and water for a long time? Or let us say you have some iron say bucket or iron vessel, and you have left it outside, so obviously it is exposed to oxygen, it is exposed to air, and let's say that the air is moist, so the air has water. So whenever iron comes in contact with air and water, what happens? Rusting takes place. So you will see that on that iron bucket you can see some reddish color layer is formed. So that reddish colored layer which is formed, that is nothing but rust. So this rust is the result of reaction of iron with oxygen in presence of water. So let us talk about rusting. Now rusting always happens in presence of oxygen and water. So that is why we say moist air. So we will talk about iron. Now in case of iron, how the exact reaction takes place. So iron is Fe. This is iron. So iron reacts with oxygen in presence of water. So it could be moist air. Oxygen plus H2O could be moist air. It could also happen that the air is dry but there is some water droplets on this iron substance. So what will this form? This forms iron hydroxide. That is FeOH whole 3. So this is basically iron hydroxide. So if you want to balance the equation, this is how it would be. So we have balanced the equation. Now this iron hydroxide later dehydrates, that is it loses all its water content to form Fe2O3 H2O, and this substance is nothing but, this is rust. So the reddish color layer or the reddish color powdery substance which is seen on the surface of iron objects is nothing but this Fe2O3 H2O, that is rust. So this is how rusting of iron takes place. And do you know, you would have seen this kind of rust in case of bridges and all. Bridges are made up of iron. So you'll see the corner of the bridges, they get rusted when it becomes quite old because it has been exposed to air and water for a very long time. Now in order to prevent rusting these days, there is a protective layer on top of iron of another metal which does not form rust. So that means rusting can be prevented. Now iron is not the only metal where rusting takes place. You can also see rusting of copper. If you look at copper vessels, you can see some greenish layer formed over it. See here, like in iron you have reddish layer, in case of copper you have greenish layer. So this greenish layer is rust. So this rusting of copper is due to the formation of copper hydroxide in presence of oxygen and water. So let us see how the reaction takes place in case of copper. Copper reacts with water, carbon dioxide plus oxygen. So this basically represents moist air. So that means the air has moisture in it. So this forms copper hydroxide, which is CuOH whole 2 plus CuCO3, which is copper carbonate. So due to the formation of this copper hydroxide, we see these green color rust in case of copper. So this is how rusting happens. So copper undergoes rusting when exposed to moist air. Now you see all the metals, they react in presence of oxygen. So that's how it is when we talk about reaction with oxygen. Now the next question that comes to our mind is, are these metal oxides acidic or basic in nature? So these metal oxides, whether we talk about magnesium oxide or we talk about copper oxide, we talk about aluminium oxide, so all these oxides, they are acids or they are bases. Now acids and bases are defined by their pH value. Now how do we test whether a particular substance is acidic in nature or basic in nature? Now we will follow the simple litmus test. You remember the litmus test? What happens in the litmus test? Okay, so in litmus test, we have a litmus paper like this. Now there are two types of litmus paper which are available. One is called red litmus, the other is called blue litmus. Now, if any solution is, so what you have to do is you have to dip the litmus paper into the solution, and based on the change in color, you can say whether the solution is acidic in nature or basic. So now what happens in this test is that if the red litmus turns blue, that means the solution is basic. And if the blue litmus turns red, that means the solution is acidic. So this is the simple funda of the litmus test. So this is how we can determine whether a particular solution is acidic or basic in nature. Now in this section, our aim is to find out whether metal oxides are acidic or basic. So how do we do that? So first of all, we have to prepare a solution of metal oxide. That means we have to combine the metal oxide with water. So how do we do that? So let us take example of any metal oxide. For example, I take say magnesium oxide, correct? So how was magnesium oxide formed? When the metal, that is magnesium, combined with oxygen, it formed magnesium oxide. So how do we get this magnesium oxide? So now if you perform the same experiment, you burn magnesium ribbon, you get what? You get ashes. So the ash which you get, that is nothing but magnesium oxide. Now take this ash, mix it with water. So you are basically getting a solution. Now in that solution, so basically this solution is ash plus water. And what is ash? Ash is nothing but magnesium oxide. That is how you have prepared this solution. Now in this solution, you dip a red litmus, and what do you see? You see that the red litmus has turned blue. So you see this was the original color of the litmus paper, but this portion has turned blue. So this shows that this solution is basic in nature. So we conclude that metal oxides are all basic in nature. Now if you try this experiment out with other metal oxides, there also you will receive the same result. If you want, you can try it out with the iron oxide. For example, you take some rust. If you find any iron material which has undergone rusting, where you can see rust, take little bit of rust, that red powdery thing, and then try to mix it with water. Even though it will not get mixed properly, but at least you try to mix it to a large extent, and then you dip the litmus paper, and you will see that case also the red litmus will turn into blue, which shows that the rust is also basic in nature. So we conclude that all metal oxides are basic in nature. Now what about non-metals? So we spoke about metals. What happens when non-metals are exposed to air? So non-metals also combine with oxygen to form oxides. But in this case, the oxides are acidic. So we will see how it is acidic and all. So let us take some examples of non-metals. For example, sulfur. Sulfur combines with oxygen to form sulfur dioxide, which is a gas. Carbon, which is a non-metal, combines with oxygen to form carbon dioxide, which is again a gas. Hydrogen combines with oxygen to form what? To form water. So you see everywhere it forms oxides. Now our next question again is going to be whether these oxides are acidic or basic in nature. So now the question is, are these non-metal oxides, they are acidic or basic? So when I say non-metal oxides, I am talking about the sulfur dioxide gas or the carbon dioxide gas which was formed. So are these acidic or basic? So for that again, we will follow the same litmus test, and for that we need a solution so that we can dip the litmus paper. So how do we prepare a solution? We will mix these with water to prepare a solution. So when sulfur dioxide is mixed with water, it forms H2SO3. That is, okay, we will tell the name later. Similarly here, when carbon dioxide combines with H2O, it forms H2CO3. And then what happens? Then it is found that when the litmus paper, the blue litmus, is dipped into the solution, it turns red. This shows that the solution is acidic in nature. So non-metal oxides are acidic. So what are these compounds which are formed? H2SO3 is nothing but sulfurous acid. What is H2CO3? It is nothing but carbonic acid. So all the non-metal oxides are acidic in nature, whereas the metal oxides were basic in nature. Now if you want to try for some other oxides, for example nitrogen oxide, when it combines with water it forms nitrous acid or nitric acid respectively. So that's how we can see that all the non-metal oxides are acidic. So this is again another difference between the behavior of metals and non-metals. So now comes reactivity of metals. So we saw that different metals, whether it is metal or it is non-metal, they all react with oxygen. But when you talk about metals, it has been seen that different metals react in different ways. So different metals show different reactivities towards oxygen. Like some of them react very fast with oxygen, some of them react very slowly, some of them even do not react at all. So here we will see that how different metals react with the same oxygen in different ways. So let us take examples of these metals, potassium and sodium. Now these metals, they react very fast. So they react very fast. So they react so fast that they can even catch fire if they are kept exposed to air, because air contains oxygen. So whenever you keep them exposed to air, they will immediately react with air and they produce so much of heat that you can actually see fire. So it catches fire. So it is that reactive. Now you take example of another metal like iron. So in case of iron, it does not burn on heating. So iron itself doesn't burn when heated. So when you are heating means you are basically supplying oxygen. So it is the reaction of oxygen. But if you take iron filings, that is small powdery iron filings, they burn when they are sprinkled on flame. So here you can see iron and iron filings, they both behave in different ways when heated. Again, if you take examples of gold and silver, gold is aurum and silver is Ag. So if you take examples of gold and silver, they do not react with oxygen even at high temperature. So there is no reaction with oxygen even at higher temperature. Even if you keep on increasing the temperature, even then also there will be no reaction. So that is why you would have seen that the gold and the silver jewelry, they are all exposed to air all the time, but nothing happens to them because they do not react with oxygen. Again, if you take examples of metals like magnesium, aluminium, zinc or lead, so all of these metals, they are all covered with a thin layer of oxide, and this oxide layer acts as a protective layer and prevents any further oxidation of the metal. So it is like there is a protective surrounding. So that protective surrounding will not allow the metal to react with oxygen. Basically, it will not allow oxygen to come in contact with the metal. So there would be no further reaction. So that's how different metals will react differently, and in a very similar way, not only with oxygen but with other things also. For example, reactivity with water or with acids or with bases. So we will see that the behavior will be little different for different metals.
Woohoo! So we reached towards the end of this video. However, there would be a next video coming up very soon. So if you really like the video, do not forget to share it with your friends. And if you have a feedback for us, do let us know in the comment section. We will be more than happy to hear from you. I'll see you all very soon with the next video. Till then, stay home, stay safe, take care. Bye-bye.